Hi everyone, I want to thank you all for joining today's Build Your Simulation IQ Composite Design webinar. Before we really get started, I have a couple questions that I want to ask those in attendance. So I will go ahead and start the poll questions. So my first question is, are you using a CAD package with your simulation design? Alrighty, so I'm going to go ahead and close out this poll question, and I will share those results with you. So it looks like 67% of those in attendance today are. So I'm going to go ahead to the next question. And that is, what type of failure analysis is more important when modeling composites? First, ply failure or progressive? So I'm going to go ahead and close that question out, and I'll share those results with you. So again, it looks like 67% are using the progressive failure. And then my last question that I have you already viewed the documentation video on progressive failure? So I'll go ahead and close that out and share that. So it looks like nobody knows or has viewed the documentation video, so this might be because you're not sure where that is located or something like that. So today we will be going over how to capture laminate progressive failure with Simulation Composite Design. We have Dean Rose, who is a product support specialist for composite design, and he will be going over, he'll be covering the topic and I think going through a demo as well. Just as a reminder, these webinars are being recorded and created on or uploaded to YouTube rather, and then also moving forward we will be sending out a link that has the PowerPoint available to users as well. So we'll email both of those to you, and then as always, if you have any questions, you can always ask the questions during the webinar, and we have a couple other product support specialists on the line to assist with those. So with that, I am going to go ahead and hand this over to Dean and go from there.
All right, thanks, Kate. I'd like to welcome everybody and thank you for attending. Today we're going to go over how to capture laminate progressive failure with Simulation Composite Design. And judging from some of the responses in the polls, it looks like we've got a good audience here today, and it looks like you're all in the right spot. So we'll jump into the presentation now. And we've done some of these in the past. And, oh, looks like I've crashed the program right off the bat. All right, so we're going to go over today what we've covered, kind of some of the building blocks that we're using to really build our foundation for composite design, how to use the program, some of the basics, and then we'll use those basics for things like this where we do failure analysis. I'll also do a brief mention of one of the programs available on Autodesk Labs. And then we'll jump into the progressive failure demo. I'll walk through some of the basic functionality and then go through a few of the questions that we get commonly and how to address those issues. And then lastly, here's a link where I'll be posting a PDF version of this demonstration. It'll have all the slides here with the links included, and then I'll also be uploading the materials that I create with this demo. So if you want to go back and repeat this and look at some of the results on your own time, you can do that as well. So this is the link for that. All right, moving ahead with composite design. You may or may not be aware, but these past webinars that we've done are uploaded to YouTube and available to view anytime you're interested. We had one that went over just what's new in Autodesk Simulation Composite Design 2015. We went over some of the new features and functionality, and then at the end you'll also see some information about just some of the basic functionality. And then we also have another one about creating and managing materials. This one goes over creating your materials and then also how to manage those libraries so you can import and export. All right, and since we've already gone over some of the basic functionality, some of the information about the constituents like matrix and fiber, we won't go over that today, but we'll be definitely using some of those aspects. And this is what we're going to be using for doing our failure analysis today. All right, the Autodesk Labs. I'm not sure if everyone is aware, but this is basically an Autodesk technology preview for various programs and products that we have we're working on. One of those for the composite team is Project Cassidy. This is a product that allows users to import their own 3D part geometry into composite design, and they can create composite plates and simulate the response. Laminates can be chosen along with the particular load configuration. And one of the What's New video has a demo of this, as well as on the this Project Cassidy link. If you go there, you can find tutorial videos, walkthrough. They also have a forum where you can post questions or any sort of defects or problems that you see. You can post those there and communicate directly with the development team. And they also post news there on what's going on with the product. So that's a great place to go if you're interested in kind of what's coming out for composite products. And as a reminder, this is only going to be available until January 6th, 2015, which is quite a ways away, but with the holidays coming up, Thanksgiving and Christmas, that cuts down the time. So if you're going to check that out, I'd advise you to check that out as soon as you can. All right. We're going to go into why you would choose progressive failure in simulation composite design, some of the factors we have for choosing progressive failure. With composite design are the capabilities. We have a lot of features available for building a laminate. You can select all your laminate materials here. You can define your thickness along with the orientations. You can also walk through quickly and apply your laminate loads, look at some of the laminate properties, and select first apply failure if that's all you're interested in, and then moving on to a more advanced analysis technique, the progressive failure. So a very capable piece of software for doing some of the more basic simulations. One of the things you'll get out of simulation composite design is some of the more realistic behavior. Composites are unique where they have multiple failure points. As you can see on the graphic here, we have a load stress strain curve, and you can see there's several areas where we have an obvious disruption in the stiffness. So That's one of the things you can extract from composite design when doing this type of analysis. And then you can also see how the load will change the stiffness, but you're still able to increase the load carrying capacity until ultimate failure. And then lastly, we have a number of controls on the progressive failure tab. Some of those controls are the ability to change the failure criterion to whatever you decide. And along with the failure criterion, we also have degradation factors that you can choose. You can manipulate those to your liking. So we also have export functionality, plotting functionality, and then the ability to create a report, which is one of the new features in 2015. And then as you can see, this is the output, so it outputs plenty of information corresponding to the current strain state. All right, so now we'll jump into the demonstration of the product, and I'll go ahead and open that up for us. All right, and I'll just start from scratch here, and we'll walk through a start to finish of a progressive failure analysis. So once you've created your laminate, you can either do this prior to doing the analysis, or you can do it on the fly. And the progressive failure information is available under the laminate, stress, strain, and strength analysis. And you can see here I opened up previously made laminate. This has the information from the last saved, so we'll go ahead and use this as a jumping off point. You can see here we have 46 plies in our configuration, and one of the features that I haven't gone over in the past but is quite useful is the library tool. So if you're getting ready to create a laminate and you have a specific configuration that you use repeatedly, you can create that using this thickness angle templates, and those are available for selection by clicking on the library button. And what it gives you here, as far as options, you can replace the current configuration, you can append it to the end, or insert it after a specific ply number. So what we'll do here, just to show and demonstrate the tool, we'll go ahead and append this to the end of our layup, and we'll just add 6 plies here. This is a 0, 45, minus 45 symmetric. So we'll go ahead, add that in there. It gives you the option of just adding a blank layup, or you can select a lamina. I like using the select a lamina because it automatically adds it in there. Saves you a lot of time. We'll go ahead and use something similar to what's already added in our material. Click OK. And we'll scroll down. We can see this is where we were previously, and we've added on our 6 plies. This isn't probably ideal to what you would be designing with, but for demonstration purposes, this will work great. So here we have those 6 plies. We already have our material configured there. If we want to change that, we can select another material. Just saves a bunch of time, especially if you're using the same layup over and over again for a design. So now we'll go to our Loads tab. We're just walking progressively from left to right, so we'll start Laminate Loads, and we'll take a quick look at the first ply failure, and then we'll jump to progressive failure, which I believe everyone is interested in. And in order to get a load, we often get a question like, where do I start for this load? And one good method for that is to go to the lamina that you're using. And here we're using a couple similar ones, so we'll just grab one of those. We'll grab this T700 epoxy. Open that up, and we go down here. We can see the strength parameters here, and we'll grab that. You can just highlight it, do a Control C, close that, go to the Laminate Loads tab, and we're just going to apply an axial load X here in the X direction. This is the strength here. We'll go ahead and ramp this up a little bit so we get past that and make sure we capture both of the materials that we're using. And you can add any load configuration in here. And we'll look at the first ply failure quickly just to see what kind of output we're getting. Oh, looks like I need to So that was just telling me that I need to add a thickness for my material. So I went back and I saw that that was 0 and went ahead and inputted something in there. We'll go back to that first ply failure, press calculate again, and we're just using the default max stress. We can use Christensen. And so what it's giving us here is the failure type. So we're having a matrix failure. Christensen is one of the failure criterions that allows us to differentiate between matrix and fiber failure. And then it's giving us the ply that it's experiencing that failure in, as well as some failure index safety factor information. All right. Now we'll look at the progressive failure tab. I'll walk through some of the options we have available. Number of increments allows you to basically break up the load application that we're applying here. So this is going to break this load into 200 increments. This is just the default. If you're doing something where you're looking for really good resolution, you can bump this up 300, 400, even 1,000, whatever you're looking for. Obviously, the more increments you do, it will increase the analysis time, but it's usually fairly quick, so it's not something to worry about. Next, we have the failure criterion available. Default is max stress, max strain. We have the psi criterion, Hasheen, Christensen, Puck, and MCT. And for this one, we'll do a Christensen failure criterion. Again, we're kind of looking for the differentiation between the fiber and matrix failure. So we'll be able to get that kind of output using this failure criterion. Next, we have degradation factors. We have factors for each direction, and we'll go ahead and knock this down. By default, it's set to 1, but when you're doing some sort of post-failure response, we'll want to go ahead and reduce that, and we'll be able to see why here. So we'll go ahead and put that at 10%. We'll leave these other ones at default. As you can see, most of them are all the same. The one that's different is MCT, and it allows you to use fiber and matrix degradation, and that's because it has the constituent materials saved in the data file, so we're able to separate those degradation factors. But for now, we'll just look at the Christensen, keep things simple. So we're back at 10%. We'll go ahead and select the calculate button. You can see everything else is grayed out until you do a calculation. All right, we have some output here. We'll just walk through what we're seeing. First column is a breakdown of the increments. We also have your stresses here in the X, Y, and your shear. We also have some strain data as well as the failure index and the factor of safety. And then these last two columns are going to be your failed ply numbers and your failure modes. And we'll scroll down and we'll see some of these rows being highlighted, and that's going to indicate a failure. So here we have, our stress and strain state, failure indexes, factor of safety, and then now we see this failed ply number column being populated. And so we can see what this means here is that we have failure in the 5, 6, 15, and 16 plies. And then we also see a corresponding failure mode. It's 1 for each of these, and those correspond, the first entry corresponds to the first entry here. So we're seeing a failure mode of 1. And a lot of times we get questions as to what does the 1 mean or what does a 2 mean. So what we can do here is we'll open up the help documentation. And if you do a quick search in the search tab, you can search for failure mode, and one of the first returns is the failure criteria and failure mode. So we're using Christensen, and we can see that 1 means matrix failure, 2 means fiber failure. If we were using a max stress, which is the default, you would see outputs of 1, 2, or 3. So keep that in mind when you're changing your failure criterion. These aren't all the same. So here we have matrix and fiber failure. We're seeing 1. We could also see 2, so we'll go back to our failure output. And as we proceed down the 40th increment, we're seeing more failure. Also modes 1. And as we go down towards the end, we'll start to see some of these plies that are now failing in fiber failure. And it lists out those plies. We can expand this out if we have a massive failure where all of them are failing. Based on what I recall from my inputs, these are corresponding to the 0 direction plies. So that makes sense here when we're seeing the fiber failure. We'll see some of the matrix failure in some of these off-axis plies. All right. So now we've seen the tabulated information. Now let's look at a graphical output. This is what a lot of people are interested in. So we do a plot here. We get this stress strain curve, and a lot of people are like, well, what am I seeing here? How can I see a definite indication of failure? And you have a hard time seeing this when you're doing a stress load on it. So what we'll want to do is do a strain displacement. So we'll go back here, and we'll actually ramp this up a little bit. I think we're just seeing the failures for the T700 material, but the AS4 is slightly stronger, so we'll go ahead and ramp this up, and we'll be able to capture everything. We'll do a quick calculate. And you can see these were shifted slightly to accommodate the increased load. And now we're seeing, before this is where we were at in our final failure increment. And upon increasing the load, we were able to see these other plies being failed. So this, as you can see, there's quite a few plies here. So this is looking like a catastrophic failure. So we'll go ahead and plot this and see what we get. So this is what we get a lot of is questions from customers saying, well, what does this really mean? You can see the stress is building, and then we get a plateau here. And if we were to carry this out indefinitely, we would just see this stiffness here continue indefinitely, and it doesn't really give a true indication of what is failing or where it's failing. To the casual observer, this doesn't really mean anything, but to the trained eye, you can obviously see something is going on here. So let's change the loading so we can get a better representation of what's happening. So we'll go to this load increment here, and we're going to capture this strain information, and we're going to use that for our load. So you can just highlight the cell, press Control-C, and now we'll be doing, instead of a stress load type, we'll do a strain. And we're just going to duplicate that strain state after failure. Go back here. And it's important when you're doing the strain calculation. Sometimes users input just the axial load, and what it's going to do is constrain these other directions almost as if it's pinned. So we want to replicate the Poisson effect that we're seeing in the material. So make sure you input all three of these loads for that strain state. We'll go back to the Progressive Failure tab. We're going to leave everything else the same and just recalculate. So now we can see the output changes slightly, and we're getting failure early on in the analysis. We'll go ahead and plot this. And here we can see a much better representation of what's actually going on. So we get this buildup, and because of the increments, we're not really seeing any of that progressive stiffness reduction. And we'll go back and we'll be able to fix that. But what we see here is this ultimate load, and then we see a massive reduction in stiffness, and then the stiffness carries out. So what we'll do is we'll go ahead and reduce this strain values that we're using for our load. So we'll go ahead and repeat this process. And you can see these strain values are much lower. And I'm just highlighting the cell, doing a copy, and then pasting this in here. Jumping back to the Progressive Failure tab, press Calculate. And we can see here we're getting several areas where we're having a few plies. These are the 45s and 90s that we're using. And then down here we're reaching this ultimate failure. And we'll go ahead and plot this again. And we're not able to quite see the stiffness reduction. Some of the materials that you'll use, you'll be able to see the softening as some of these matrix plies fail, but you'll be able to see the stiffness continue until you see your ultimate load here. And then we see this corresponds to the area where we're experiencing that massive failure of those plies. So that's one of the more common questions that we get in regards to this. And then also, if you're doing multiple iterations and you want to capture all the inputs that you're using here, it's difficult to kind of tabulate all this information for your history. So you would take advantage of this Add to Report. If you're not interested in capturing all of these strain states where we're not seeing any failure, you can select the Remove Non-Fails tab, and that goes through and just keeps all the failed rows for the historical report. And then we'll go ahead and add this to report. We have one existing already. And here we can see as we scroll down through this report, it'll give us all the information about our materials that we're using, strengths. It gives the constituent values as well as the layup that we're using, some of the ABD Q-bars data, and then scrolling all the way down we get to the 2D and 3-dimensional properties, and now we're into the laminate analysis portion of the report. We can see some of this information as far as our loading, the degradation factors that we use, the failure location, and then here is the progressive failure results. And then lastly, we have that stress strain curve that we produced. And if you want to do several more, you can go through and you can add all of those to this report. So it's a great tool. There's obviously some limitations. You know, this is for a simple setup where you're just interested in looking in what plies are going to fail. you'd want to use a more complete FEA tool if you're looking at damage progression, delamination, some of those damage zones. If you're looking to capture that level of information, this isn't the tool that's appropriate for that. But it will give you some information beyond what you see for that first ply failure. So if that's interesting to you, this is a great feature. So, and then go ahead and close this down. I think I've covered everything for this laminate. So I wanted to keep this kind of short and sweet today. Jump to my PowerPoint here. And in summary, today we've covered some of the information for our labs. That Project Cassidy is available. I encourage everybody to go and check that out as soon as they can. It's a great new tool that we're developing, so the development team would really appreciate any feedback for those of you that have already used it. So feel free to jump on the forums and post any comments that you have. We've also covered some of the videos that we've done previously. So if you have any questions about how to create a fiber or a matrix or importing materials, you can go back and review some of those videos, and we go over a lot of that information. So, and then lastly, I have this box account here. There's a folder. You can go here. I've already saved a PDF version of this presentation, and I'll also be uploading the material that I used for this, so you can go back, run through this, duplicate the results that you see, kind of manipulate some of the degradation factors and see how that affects your results. And then if you have any questions, feel free to reach out to us. And then lastly, we'll go through. If you have any questions, feel free to stay on. If you don't have any questions, you can jump off at any time, and we'll try to go through some of the questions that you guys have. So I want to thank everyone for attending, and we'll be online. I've got Mike Lebsack, who's one of the documentation gurus here at Autodesk, and he'll be assisting with some of the questions. So feel free to fire away, and if not, have a great day.
Hey Dean, it's Kate.
Hi, Kate.
We did get one message that came through that said, if I want to view the FEA results fed back from this data, what software do I need?
So the FEA results, are you interested in the stress strain data that's getting output? I'll go ahead and open this back up. So is this some of the information that you're interested in? Or are you interested in the Project Cassidy?
They want to see the graphical output.
Okay, so for this, if the graphical output you'll be seeing is from the plot, so this would be the stress strain curve. If you're looking for like for example, a plate with a hole simulation where you'd actually be able to see a differentiation between like failed and non-failed, that would be using the FEA tool, and Simulation Composite Analysis does a great job of that. So I'm not sure if that's what you're looking for. But as far as like the actual structure and being able to see like a failure cascade there, you wouldn't be able to extract that here. We're just looking at values for the stress strain results.
They came back and asked, does the FEA simulation incorporate these results?
So for this, we're not actually doing like a finite element solution. This does use the progressive failure. So what we're going to do is once we see the failed ply, we're going to have that stiffness reduction applied to it. As far as exporting this back to like an FEA platform, I'm not really sure that's possible, but I may not be understanding the question correctly. So. And we can follow up after this if you want. We can have a one-on-one discussion.
Yeah, so maybe one point of clarification here. Composite Design doesn't use any FEA for this progressive failure tool. These are all closed form solutions. To do the FEA, as Dean mentioned earlier, you'd want to use our composite analysis tool. And in that sense, you're able to view, I think what you're sort of getting towards here is the contour plots and individual element failures. So for that, the composite analysis tool is a great option for you. Yeah, so your question here, what if I want to view where the individual failures are? Composite analysis would be the way to go there.
And in the future, right now we're primarily focusing on simulation composite design. Just trying to get these webinars started. We thought we'd start with something simple that has a larger user base, and then we're actually looking at expanding this into composite analysis. So in the future, you'll probably see some of these. We'll go through some progressive failure webinars where we actually look at some of the stress strain information using a full-blown FEA analysis with ANSYS or Abacus. And you can see the level of detail that we'll be getting from there. And then if you have any questions about what the capabilities are, we can put you in touch with some of that information. So. All right. Are there any other questions coming in, Kate?
No, it doesn't look like it at this time.
Okay, we'll just hang on for a few more minutes here. We won't want to keep everybody going all morning, but feel free, chime in. If you're just looking for any additional information about composite analysis or any of the other functionality, go ahead and submit it. And if we can't get to it this morning, we'll follow up with you after and provide you with all the information. So I noticed we didn't get anyone that has viewed the documentation video for this, and it goes over a very similar kind of a tutorial, creating the laminate and then going to the progressive failure. You'll hear Mike's voice on this video, but that's actually also available on the documentation. So if you just go to the main Simulation Composite Design 2015 help page, you can select under videos, pop that out, and then you'll see this progressive failure analysis, and it walks through just a very basic analysis here. So that's available, and then we also have some other information there. So it's a great tool for you. All right. Well, we're not seeing any other questions come in. If you do have any questions after we end this, you can always post those on the forums. We're all looking at the forums, from developers and QA to product managers. Mike is on there quite a bit. I also get on there, try to answer people's questions. Sometimes they're just composite questions in general, or they're specific to a specific feature, maybe a defect or something someone's seeing. So I invite you to jump on there, and you can also submit a support request if you're interested. So I think that's all we have for today. I want to thank everybody for coming and participating. Thank Kate for introduction and guiding this, and then also thank Mike for jumping in. We try to get as many people from the product teams involved as we can, so get this information out to our users. And that's all I have, so thank everybody and have a great day.